Friday, we talked about solving right triangles using right triangle trig and setting up the three equations using sine, cosine, or tangent. And each one of those examples we solve for a side. The other component of the trig stuff is to be able to solve for angles. So what? Somebody gonna explode soon? You heard that, right?
Yeah.
Okay. Don't make me back in, Judy. We're going to solve for angle A, and even though Friday I was preaching about how you shouldn't use any calculated distances, or angle measures for that matter, we're actually going to cheat to find angle P. If I know angle A, how do I find angle P? No choice theorem. No. No. Johnny, you raising your hand? You just stretching, doing some weird form of desk
my hand,
yoga?
but I took it back.
Why?
Wouldn't you just like subtract from 180, 90 and angle A?
Beautiful.
Isn't that the no choice?
Triangle sum.
No choice theorem has to do with two triangles.
Oh, okay. Well, it's the same like idea though. Like you subtract the other stuff. Was there a shorter way to say what you said? Like you
Isn't it triangle something?
He said triangle sum theorem.
Oh,
Yeah, that's how you
He said
do it.
triangle something. Okay.
In essence, yeah. I mean, that's not exactly what he said, but he said subtract from 180 and subtract 90 and then
No, that's what I was asking. Like, what's the name?
triangle sum theorem,
Okay.
which is what he said.
Okay.
He kind of paraphrased it,
Yeah.
but eventually he got to that. All right, after all that took a lot longer than I figured. What's the relationship between angles A and P? Are you raising your hand, Amber?
Yeah.
What do you got?
Angle P is smaller than angle A. Is that what you wanted me to, or no?
That is a true
Okay.
fact, yes. In this particular case, angle P is smaller than angle A. How do you know that, by the way? Let's pursue that a little bit.
Because the AE is shorter than ED.
Small, medium, large theorem.
Yeah.
Well done. Yes, sir.
They're complementary.
They are complementary, which means what? I mean, I like you throwing around the big words and everything, so you seem like you're really smart, but
They add up to 90.
they are up to 90 degrees. Good. So eventually we're going to figure out, I mean, in probably another hour and a half, we're going to figure out how big angle A is. And then once we get angle A, if we just take that value and subtract it from 90, we'll get angle P. Okay, so how do we do that? We use something called an inverse function. So an inverse function undoes a function. If our function, for instance, is squaring, you undo squaring by taking a square root. You undo addition by doing subtraction. You undo multiplication by doing division. So every function has an inverse function. The inverse functions for trig are above the trig buttons on your calculator. Go ahead and find those. So if you look above the sine button, you will see something called an inverse sine, which looks like this. That's not a reciprocal. That's not sine to the -1 power. That's the inverse function. It undoes sine. So we got that? Above sine, cosine, and tangent. The tricky part is knowing when to use them. So I've reduced that into a simple process, which I left off in my slideshow. If I set up this equation, the sine of A is equal to 4/5, there's nothing new there. We did that on Friday. Going back to the picture, you take, I forget, what's sine again?
Opposite over hypotenuse.
Opposite over hypotenuse. So in that case, the sine of angle A is the opposite side, which is 4, over the hypotenuse, which is 5. We want to solve for angle A. So the step I left out is that if I have the sine of angle A is equal to 4/5, I intentionally left some space there for a reason. How do I undo the sine function?
Divide each side.
No, not divide.
Negative.
The inverse. Take the inverse of the left-hand side. Basic rule of algebra, whatever you do to one side of the equation, you have to do to the other side. What happens when you take the inverse sine of the sine?
They cancel each other.
Oh, who's the one on the far left?
This one?
No.
No. This one. You sure?
No.
Yeah, it was. Whose is this?
Sorry.
Catch.
Oh, no.
Turn the vibrating function off or put it in airplane mode.
Okay.
Unless Dan punch you in the head.
Here it is. Back.
Throw it back. That was a horrible throw.
Sorry.
It's a good thing I've got mad ninja skills.
Yeah.
Do this on your calculator. Inverse sine of 4/5. And what dost thou get? Yes, sir.
53.13.
Is that a reasonable answer?
Yes.
Branch, you think that's reasonable? Yeah. What would be an unreasonable answer? What answer would you get that you're like, that might be wrong? Shh. Baranch.
Is this referring to like the triangle previously?
Sure.
Okay, then
Or any triangle for that matter.
was like
What would not make you happy?
was greater than it was like it was 90 degrees.
Good. Bigger than 90 degrees would be bad. Anything else?
If angle A was opposite a side that's smaller than the other side.
Beautiful. Didn't satisfy the small, medium, large theorem. Anything else? No. So you're good. Okay. So those are two things you're going to be looking for. That might be a red flag to say, I think I screwed up somewhere. Excellent. Do you want to contribute to this mess?
Yeah. Also, if it's like a negative number.
Negative angles are not good in this class. No, no, no. We don't deal with negative angles. How do you find angle B? Sorry, it's not B, it's P. We just spent 20 minutes talking about this. Yeah.
Subtract A from 90.
Yeah, 90 minus the answer on your calculator, and you get angle P is equal to 36.87. Did I do that right? Okay, good. Okay. So these all come from setting up that same equation. The equations that we set up Friday are the same equations we set up today, except that you have to solve them a little bit differently. Okay, let's try this one. So this says solve the triangle. That's a fairly common phrase. Solve the triangle means find all 6 chunks of information. We're given 3. We need to find the other 3. By the way, what are the 6 chunks of a triangle? 3 angles, 3 sides. I would suggest we start this problem like by drawing a picture. It's a right triangle. What do you want to call this vertex?
B.
B,
A.
A, 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 B, B, A, B, B,
Q.
B,
Y.
A, Q, Q. Why Q?
I don't know.
Doesn't matter.
No.
Doesn't matter. So we'll do B. So this guy is
A.
A, and this guy is
C.
C. Good. How long is this side?
C.
C, because we don't know how long it is. That's a lowercase c. How about this one?
18.
18. Could also be B, but we know that B is 18. And this one?
13.
13. Make sure you label the triangle correctly. If you don't, it causes all kinds of problems because the side opposite is not necessarily the correct opposite side. Okay, we good? Yeah? All right, here we go. Olivia, what do you want to solve for first?
C.
C? How would you solve for C?
Would you do? 1 second. Would you take the negative sign? No.
No, because that'll give us an angle.
Oh.
You're overthinking this. Look at the picture. How do you solve for C?
Oh, Pythagorean theorem.
Beautiful. 13 squared plus 18 squared equals C squared. Pythagorean theorem is a legitimate tool that we can use here because we know exactly the length of 2 sides. Okay. Normally, if we calculated the length of a side, we don't want to use Pythagorean theorem because we're using calculated information. But this works out just beautifully, and C turns out to be So are you defining 22.2 as messy?
Well, no, that's not exact.
Okay, but you stored it, right?
Yeah.
So if you need it later, maybe you want to do something crazy like store it into C. Are you all comfortable with storing it into C? Yeah, because you got the alpha button there, so you've got 26 options.
Like,
Well-
does that mess up your storing in programs or
Nope. Because your program will just restore whatever you need in there.
no? Okay.
You can't delete stores, you can just store over what you've already stored. Unless your program is something that requires that a certain value be stored, then, you know, like if your Frogger program requires that C be 6, then you're screwed. Yeah,
Could you also do like the sin of
the what?
the sine
The sign, yes,
of
that's
A?
what I thought you said.
Yeah, I did.
Hold
say
on, we're getting there in a second. In order to solve for C, because she wanted to solve for C, we want to use Pythagorean theorem for this one.
But you could use the sine.
You could do lots of things, yeah.
Okay.
When it says solve the triangle, we like look at the angles too.
Mm-hmm. All right, Olivia, back to you. A or B would you like to solve for first? There's not a right answer, by the way, either one. It's just a personal preference. Don't stress over it, just.
A.
Now, it seemed like a real taxing decision. It does, there's no, you're okay with A?
Sure.
Okay,
Yeah.
all right, let's solve for A.
Oh my. Okay.
All right, from angle A, is the 13 the opposite, the adjacent, or the hypotenuse?
Opposite.
Shh, Olivia.
Opposite.
Beautiful. And is the 18, because we want to use given information, not calculated information, we want to stay away from the C, is the 18 the adjacent or the hypotenuse?
Adjacent.
Beautiful. So what function uses opposite and adjacent?
Tangent.
Lovely. Set up an equation. The tangent of angle A is equal to 13 over 18 or 18 over 13? Olivia.
13 over 18.
Beautiful. Whoops. Hold on, I forgot to leave space. Okay, Olivia, how do I get angle A by itself?
You would do A equals tangent of 13 over 18.
Not tangent,
Oh, negative. The negative thing.
inverse tangent.
Inverse.
Yeah.
Tangent.
Take the inverse tangent of both sides. Let's keep our math clean here. Inverse tangent of the tangent cancels, so A is equal to the inverse tangent of 13 over 18. Plug and chug, and what do you get?
35.884.
0.84. Units?
Degrees.
Degrees. Raj, back to you. You okay with that? Anything bother you about that angle measure? No, it's positive. It's less than 90.
Yeah.
It satisfies the small, medium, large theorem.
Yeah.
So you're happy.
Yeah.
And if you're happy, I'm happy. Beautiful. Olivia, back to you. How big is angle B?
Angle B is 54.16.
I assume you took 90 minus 35.84. Beautiful. If the triangle is solved, we should have 6 pieces of information. 1, 2, 3, 4, 5, 6. We're good. Now, there's another way to solve the problem. We could have solved for one of the angles and then use the angles to solve for C. Would it make a difference? It might. It might be off by a hundredth or so, but we want to try to stay with given information versus calculated information as much as possible. Any questions on this process? You notice how important labeling the triangle is to start, because if you label it incorrectly, when she starts doing those angle calculations, you're not going to be setting up correct trigonometric equations, and it screws up everything. Any questions before I erase? Okay. And that, over here. Okay. You are standing 100 feet away from the flagpole. The angle up to the top of the flagpole is 37.5 if your eye is 5.5 off the ground. So we're taking a more realistic approach here. You're not going to go outside and lay your eyeball in the grass and measure the angle. You're actually gonna stand up straight and measure that angle up to the top of the flagpole. So solve for the height of the flagpole. I would suggest you draw a sketch first. And we'll make sure everybody's got the correct sketch before we proceed, because with the wrong sketch, we will be in a world of hurt. We need to make two assumptions to solve this problem. What are those assumptions? Yes?
That the flagpole is perpendicular to the ground.
Number one is that the flagpole is perpendicular to the ground because most flagpoles would be perpendicular to the ground. And? Yes?
Well, I was just wondering, are they saying the angle is from the eye to the flagpole?
Yep.
Okay,
Up to the top of the flagpole,
right.
from your eye.
Okay.
What's the second assumption we're gonna make? I can answer that question with a joke if you'd like. Will you name a woman with one leg shorter than the other? Eileen, correct. You really need me to explain that joke, Julio?
Oh,
You got it? Okay, good. We're assuming that you're standing perpendicular to the ground, you're not leaning. Anybody got a picture of the situation? No? Kind of, maybe? All of you drew triangles. It's not a triangle. Here's the ground. Here's the flagpole. Go ahead, I'm listening.
Isn't it just it's some sort of quadrilateral?
It is? What kind?
Uh, nope. I thought I had it. I don't know. Is it? No. I don't know.
You've lost some weight, by the way. Congratulations.
What? Oh, thanks. I was like, yeah, thank you. Tell me I lost weight. It's nice.
That's actually kind of creepy if I was talking.
Yeah, you
Yeah.
do.
Ew. What shape is that? It's a trapezoid. This is parallel to this. Trig doesn't apply to trapezoids, so how do we solve the problem? Oh, by the way, this is 5.5. We know that. We know that this is a hundo. Yes?
You have to like make it like a triangle like that. You have to like cut it off at like the 5.5, and then you just add the 5.5 onto the height later after you solve for that side.
There we go. We'll call this distance x. We'll solve for x, and then when we're done, we'll add the 5.5 on. Similar to the notebook problem we used to find the height of the building. Okay, we ready? Galen, you're up. What function are we going to use? You want to go from scratch, by the way? Where's the 37.5 degree angle? Up at the flag or down by the eye? The angle to the top of the flagpole is 37.5. And it's going to follow a little bit of realism here in that you're not going to easily be able to measure that angle up at the flagpole, but we can measure this down here with a protractor and a straw. Okay, so let's deal with the x first. Is the x opposite, adjacent, or hypotenuse? Good. And is the 100 adjacent or hypotenuse? Adjacent. Which function uses opposite and adjacent? Shh. Beautiful. Tangent of 37.5 is equal to x over 100 or 100 over x, Kim? Well done. Solve for x. Notice this one, we're not looking for an angle measure, does not involve an inverse tangent. Straight up tangent problem.
Wait, when do you use inverse tangent?
When you're looking for an angle. Kaylin, what do you got?
76.7.
And those are feet, right? So therefore our final answer is that plus 5.5. So 84.2? Did I do that right? No, not even close.
82.2.
82.2. I was close. Feet. It's a big flagpole. That's really big. How big do you think our flagpole is out front?
30 feet.
30 feet?
No.
No, tw- right,
21.
21 feet.
Yes.
Anybody else? 26.
Hey, why don't we go measure it?
23,
Holding a
32,
protractor up to
7.
That's a great
your
idea.
eyes.
We could start a pool. Everybody throw in some money. Whoever's closest wins.
Yeah.
You guys want to gamble on the height of the flagpole?
Yeah.
Yeah, yeah. All right, good. We'll work that out. We're not going out in the cold though. I'm not traipsing through the snow. But we can measure the flagpole. We got about 6 different ways to do it. So when the weather gets nicer, we'll go out and measure the height of the flag. Have class outside, maybe a picnic,
That'd be so fun.
like a little brunch. We'll just put a blanket out, have a little snack. So think about next time you're getting on one of the school by, be sure to look and see how tall you think that flagpole is.
School buses.
'Cause we'll figure that out when the weather gets nicer. Okay? Any questions with this? Notice again how important the picture is. If you draw the picture wrong, then you got a different scenario. That's not to say that I won't ask you questions where you're in a realistic situation, your eyeball is laying in the grass. But since I told you the height of the person, then you can assume that you're actually measuring from a distance above the ground. Okay? They get this little rectangle down at the bottom, but all that matters is that you add 5.5 down to the final answer. Okay. One more example. Solve for x. When you get an answer, check with your neighbor to make sure he or she has the same answer. If not, start fighting to the death. There's the challenge, Greg. Same answer.
No. 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 Oh,
You got the same thing.
yeah. Yeah. Sorry. I don't know how to read numbers.
Alright, what did you get now? Did you finish it? Are you still working on it? God damn, George! He's not done yet.
Alright, 63.4?
Oh, no.
I just messing you, that's not the right answer. See if I can. Shut up. Alright. Let's see. Joseph, what do you got? Did you get the right answer by the way? 50, what is it? 50?
51.3.
51.3? Beautiful. Alright, what function did you set up?
I did the cosine of x is equal to
Hold on. I have to reteach myself how to use my own board. Let's try that again. Not your fault at all. That was me not knowing how to use the technology. The cosine of what?
of x is equal to 10/16.
Beautiful.
And then I did the inverse function.
Love it. Got to sneak it in there. I didn't leave enough room. So the inverse cosine of the cosine.
They like
Do you want me to help you?
yeah.
Are you having a brain fart?
Yeah.
They cancel?
Yeah, they canceled
good.
out, sorry.
I understand.
And then that's when I got 51.31. 32.
3-2. Well done. Any problems with that guy? Straightforward problem, set up your trig equation, solve the trig equation. Any problems? It doesn't matter if you're solving for a side or for an angle, you go back to the original trig equation and you figure out, once you get it set up by looking at, I know the opposite side, I know the hypotenuse, I know the opposite leg, I know the adjacent leg, blah, 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 blah. Set up your trig equation, solve for whatever chunk of information you're missing. Remember, when you're solving triangles, try to avoid using calculated information. And anytime you get an answer, just get in the habit of storing it in your calculator. It doesn't matter, it's not like you're gonna fill up the memory in your calculator. It just stores over it every problem. We good? Any problems? Okay, so you got two things to do then. The first thing would be to finish the problems from Friday that you were unable to finish because we hadn't covered the angles yet. And then the next day, which is the second day of 8-4, is on Schoology. All right, so you've got a good chunk of time. What do you got, 22 minutes, I think it is? Quarter after, right? Okay, I got 22 minutes to start knocking those out. I do, however, want to take a look at one example. On the homework tonight, they ask you to solve for an exact angle measure. Problem number 1 says, what's the sine of 60 degrees? Now, you could punch it in your calculator. Go ahead, punch it in your calculator. What's the sine of 60? .860, blah, blah, but that's not what they're asking you to do. They're asking you to use the special right triangles to solve for these values. So I'm going to show you the technique, and then this technique you should be able to use for a 30-degree angle, a 60-degree angle, and a 45-degree angle. We're looking for an exact answer. So I'm going to use the general form. If this is the general form of a 30, 60, 90 triangle, how long is this side?
5.
Nope.
Half the-
A. How long is this?
Square root of 3a.
A square root of 3, and this?
2a.
2a. So we're doing 60 degrees. Sine is what?
Sine is opposite.
Opposite over hypotenuse. Which side is opposite the 60-degree angle?
A squared is
A squared of 3. What's the hypotenuse?
2a.
2a. Oh, look. Whoopsh, whoopsh. Square root of 3 over 2. Christelle, just for giggles, could you punch the square root of 3 over 2 into your calculator and tell me what you get for an answer? Oh, same, right? Nice. So this number matches the number that she calculated when she took the sine of 60. I'm not looking for 0.86 blah, blah, blah. I'm looking for the square root of 3 over 2. And you can do that for any one of those angle measures, 30, 60, or 45, using the general forms. Let's do one more together just for funsies. What's the tangent of 45 degrees? 45, 45, 90 triangle. How long is this?
A.
A, this guy. A, this guy.
2a.
No. A squared to 2. Tangent of 45 degrees. Tangent is opposite over adjacent. Opposite side from that 45-degree angle is? A. The adjacent side is? A over A is
1.
1. Go ahead, Christelle, tangent 45.
1.
Shazam. Same. Good job. Question?
Does it matter which special right triangle you use?
Yes.
Do you have to use both then?
Yes.
Okay.
Yes.
So then what side is that you've come up?
What side?
Yeah.
S-I-D-E?
Do you
Like
not
stuffing or mashed potatoes
Yeah,
or?
Like, do you not
clean
find
corn?
the side with that, or is it just like a
Nope.
number?
This is, so somebody asked when I first started trig, where do these numbers come from? This gives you a hint as to how the magic happens. It's like the Disney of trig. This is where the magic happens.
So it's not a side.
Nope,
You can't find the
Nope.
sides with these.
nope.
Okay.
What you're doing is you're finding the trigonometric value of special angles. So like if you take your calculator and hit tangent 27, it spits out some weird number. And initially we said, well, that's just magic and we don't care where it comes from, it just happens.
Okay.
This gives you a glimpse into where it, or how it happens for certain angles.
Don't you have to like draw that circle and then like?
Colored purple.
Yeah, exactly.
Uh-huh.
But like you make it like an angle
Now you got the chills.
on the bottom.
You guys have any idea what I'm talking about?
No.
Kaylin, you with me?
Isn't it like the thing on the back?
Yeah, and then you crack an egg and then yeah. I don't remember how the whole thing goes, but
We did like around the world in 80 days as marks the spot.
that one I'm not familiar with.
I thought it was 3.
I'm familiar with one that was like make a circle color purple and then you crack an egg on their head and it runs, no?
Yeah.
I was
I
like,
Yeah, you make a
X
fist and then
marks
you
the spot.
and then it-
From a big boulders, one tiny rock. Remember that one?
Is that a Jewish nursery rhyme?
Spot and rock do not rhyme.
I don't know. No, it's like what's that called? That's called like
A half rhyme?
Crazy?
No, illusion. ALOUSION.
Illusion.
Yeah.
What is that?
Is that when you get together with a bad guy and plan a crime?
No,
that's collusion. Sorry.
Yeah, no.
Illusion?
Yeah.
Not illusion, like
No,
magic.
No, illusion.
Illusion.
No, that's where it's like kind of rhymes. It
No.
like
No.
yeah.
That's a
I know
half
that's
That's a
not what an
reference.
illusion is, yeah.
No, wait, no. Hold on.
What do you
An
actually
illusion is
say?
like
It's a
No.
half rhyme.
That's a half rhyme.
Yeah, that's what they call it. It's a half rhyme.
No.
A half rhyme?
Yeah, it's
Yeah.
literally
No,
called a
that's
half
the
rhyme.
stupidest thing I've ever heard.
It's when it like half rhymes with the word.
Yeah.
Like snail and snark?
Yeah, like
No.
hinge and like orange.
They like end similarly and they sound the
that.
same, but they're not the same, like spelling.
No.
No, that's a
Oh, like
homonym.
they're- No, but they rhyme.
C and C.
But they rhyme. But they rhyme.
No, where it's like.
Hey, Erica, what did one ocean say to the other ocean?
Nothing makes.
Don't know? They didn't say anything, they just waved. Did you see what I did there? You sure did.
Stop.
Must be my delivery. I don't know why my jokes never get any laughs, but yours everybody cracks. You got one for today? Since we haven't added Jewish fast facts into today?
Yeah.
No, we just had the Jewish nursery rhyme.
Wait, but so if it's a
Wasn't it
story,
you?
then you don't have to do 45.